Explain with suitable examples. Ferromagnetism. What is ferromagnetism? I'll just tell you a few points. If a substance is strongly attracted by a magnetic field, it is called ferromagnetic. Okay. If it can show permanent, magnetism, then it is also called ferromagnetic. So this is the definition, the first point. The substance which are strongly attracted by a magnetic field and show permanent magnetism, even when the magnetic field is removed, they are called ferromagnetic substances. Yes, this is the first point. In fact, this can take a second point. Third point, when there is spontaneous alignment of magnetic moments of domains, each solid has certain small portions, some collection of atoms which are called domains. And these domains happen to have, when each atom functions as a very small magnet, a collection of such atoms, maybe say 1 million atoms combined together, and you get a domain, and they are such that all those atoms have magnetic fields only in one direction. So this is the direction of magnetic field of a single domain. And if all these domains actually get aligned in one direction, my God, all their magnetic power adds up and I get a ferromagnetic substance. Yes. Do we have any example? Yes, we have examples. Iron, cobalt, nickel, gadolinium, CrO2. These are substances which can be used for making permanent magnets. Wow. So there are 4 points. 2 marks question. Ferromagnetism, you could write a note like this and you could draw also. These are the direction of domains. What about paramagnetism? Whenever any substance, if you look at atom of any substance, obviously that atom contains electrons, yes. And each electron is moving. And moving electron means current. Moving charge is current, please note. And each current is associated with a magnetic field. Wow. So there is magnetic field which is generated within an atom because of movement of electrons? Yes. And since electrons are spinning in the opposite direction, these magnetic fields can cancel if there is a pairing of electrons. So if there is pairing of electrons, their magnetic fields are in opposite directions and they cancel out. But if the atom contains an electron which is unpaired, that means it has a net magnetic field which is not cancelled. That means every atom functions like a very, very small, tiny magnet. Right. Such substances in which the fundamental units like atoms or molecules have unpaired electrons, these atoms or molecules begin to function as very tiny magnets, and such substances are said to be paramagnetic. Such substances are said to be paramagnetic. Wow. These are attracted in a magnetic field? Yes, these are attracted in a magnetic field. And if these substances are placed in an external or a strong magnetic field, the atoms which are functioning as magnets themselves, all of them get aligned in one direction in that magnetic field. So that is the idea of paramagnetism. The substances which are weakly attracted by a magnetic field, okay, that is first point. They're magnetized in a magnetic field, they undergo temporary magnetization, that's fine. And they lose their magnetization in the absence of magnetic field. See, in the direction of an external magnetic field, they're all aligned in one direction. But the moment you remove it, they become random. So in domain theory, if you're just checking their domains, they are random domains like this. This is an absence of a magnetic field. If you apply an external magnetic field, they will all come in one direction. You remove it, they again go back. So they have a temporary kind of a magnetic behavior. Then third point, paramagnetism is due to presence of one or more unpaired electrons. Wow. And examples, that is the fourth point, dioxygen, copper ions, ferric ions, chromium ions, anything which contains unpaired electrons, that would be paramagnetic. 4 points for paramagnetism as well. Ferrimagnetism. This is very interesting. What happens in ferrimagnetism? You find that a substance may be paramagnetic, fine. So it should have a tendency to show some magnetic character, yes. But somehow you find that it is not very strongly magnetic. What happens is that in solid state, their magnetic domains may not be completely aligned all in one direction. Some of them are in one direction, some of them are in opposite direction, and they partially cancel, not completely. They partially cancel each other. That means the net magnetic field is reduced. It's not very strong, but it is there. And such substances are called ferrimagnetic. So, it is observed when magnetic moments of domains in the substances are aligned in parallel and anti-parallel directions in unequal numbers. See, in unequal, three of them are in one side, one on the opposite side. Fine. Second point, they are weakly attracted to magnetic field. Yes. Third point, examples, ferrosulfuric oxide Fe3O4, ferrites MgFe2O4, ZnFe2O4 are examples of such substances. Yes. And fourth point, these substances also lose their ferrimagnetism on heating and they become paramagnetic. Let me warn you, ferrimagnetism or ferromagnetism is observed only in solid state. Paramagnetic can be solid, liquid, gas, anything. Ferro or ferrimagnetic has to be a solid substance, and that too, beyond a certain temperature, they lose their magnetic character as well. There we are. Antiferromagnetism, that is one step above ferrimagnetism. What happens? If all the domains exactly cancel each other and the solid state substance exhibits no magnetic property, then they are said to be antiferromagnetic even if they are paramagnetic. I mean, see, like manganese oxide, they have domains aligned like this. Some in one direction and same number in exactly opposite direction. So although individually atoms or molecules might be paramagnetic, yes, but overall the solid substance shows no magnetic character. Why? Because it has become anti-ferromagnetic. Okay. Their domains are oppositely oriented to each other and they cancel out each other's magnetic moment. Yes. So this is one point. Second point is this. Third point you can draw a diagram, and fourth point you can say it is only in solid state. It is exhibited only in solid state, and that too if you heat them beyond a certain point, you find that they are not even antiferromagnetic. They lose their orientation, they become random, and of course they become paramagnetic. Right? There we are. Lastly, 12, 16 and 13, 15 group compounds. What are they? 12, 16, one at like, it could be something like ZnS, oh my god, or CdTe, zinc sulfide, cadmium telluride, mercury selenide. Lovely. One of the atom belongs to group 12, zinc, cadmium, mercury, and the other atom belongs to group 16, oxygen, sulfur, selenium, tellurium. And these are said to be 12, 16 compounds, and they can function as semiconductors. You also have 13, 15 compounds like, BAS. What is BAS? Boron arsenide, or ALAS, aluminium arsenide, or it could be GAP, gallium phosphide, or I mean, just such stupidities. What I mean is, you have these as group 13 elements and you have these as group 15 elements. If they combine together, they would give you very funny compounds, and each of them functions as a semiconductor. That is their special property. So dears, this is all about the NCERT discussion of solid state. I'm sure you have benefited from it, you've enjoyed this, and if you have liked this and if you would love to explore more, download the Vyas app. Talk to us. We are there to resolve your doubts because this is what we are supposed to do as teachers. And not just that, you can also check out our courses for IIT JEE, NEET and board exams on Vyas app. Welcome to Vyas.